Now this is the circuit diagram for verification of Ohm's law. We are having a cell. Say this is positive terminal of cell. This is negative terminal. The positive terminal of cell's key you can place here also, here also. You have to place it near the cell or where the whole current is passing. So that when you switch it off, means the dot shows the key is on. And when we don't put the key, means the dot, then it means the switch is off. So it should have, the whole current should pass through it. So that when you switch it off, then the current in the circuit should become 0. The positive terminal of cell should go to positive of ammeter. Then negative of ammeter is going to 2 points, voltmeter positive and resistance. And other end of resistance and voltmeter negative is going to rheostat. And rheostat other point is coming to cell. Now when you take the readings, so we have to measure the readings of ammeter and voltmeter. So for that we have to understand the concept of least count and range. Now range is the maximum value that we can measure by any instrument. Like for example, if it is written 0 to 3 ampere, it means maximum 3 ampere current can be measured by that ammeter. Or similarly 0 to 5 volt means maximum 5 volt can be measured by that voltmeter. Now when least count, the least count is the minimum accurate reading that can be measured by the instrument. If the least count is smaller, then the instrument is said to be more and more accurate. So if we are having the option to select the ammeter or voltmeter, then we have to see the least count. अब say for calculating the least count, the simple rule is, say for example this voltmeter we have taken. The simple rule is, first of all see the value where first value is 0, then the next value is written 2. So count the number of division from 0 to 2. Don't count the division 0. So we are at 1, 2, 3, 4. Means the where the value is written, we have to count that division. So we can say by simple unitary method, 4 divisions are 2 volt. So least count will be 0.5 volt. Means divide the value by the number of divisions. Now importance, when we say importance of least count, it means whenever we read the reading of the instrument, like it will be 2 divisions or 8 divisions or 10 divisions, so that is always the multiple of least count, because value of one division is least count. Second, so we can say reading of any instrument is always the integral multiple of its least count. Secondly, if the least count is till second decimal place, so we have to give the answer till that many decimal places. And if the least count is smaller, the instrument will be smaller. We can say more accurate. Next thing is zero error. The zero error means if the normal case, if we are not using the voltmeter or ammeter in the circuit, or you can say the normal scale, they always start from 0. But if somehow with the frequent use of the instrument, say 0 point of the instrument is not at 0, means the pointer is not at 0 when we have not connected it in the circuit, then the instrument is said to have zero error. It can be positive or negative. If the pointer is ahead of 0, like in this case, then the zero error is called positive. If it is below 0, then it is called negative. For calculating the zero error, rule is simple. Calculate the least count of the instrument, and if it is ahead of 0, then put positive sign and multiply the division of pointer by the least count. Like in this case, least count is 0.2. So positive zero error is plus 3 into 0.2 or plus 0.6 volt. Similarly here, negative zero error is minus 2 into least count, minus 0.4 volt. And we have to subtract the zero error with sign from the observed value in order to calculate the accurate answer.